We start Module 3, Recursive Algorithms. Part A, Introduction to Recursive Algorithms. 8.1, First View of Recursive Algorithms. All right. First, we like to see this question. Why recursive thinking is important in problem solving? So in problem solving, we use many different ways. There is one big important way. It is recursive way. Yeah. So first, let's look at why it is important and what is the problem it still have, so this method still has some problems. Yeah. So we want to understand that part. All right. So usually for people who do not have this training, recursive thinking training, so they are used to straightforward thinking, so non-recursive. So they like to do things step by step, the natural way. Yeah. So usually people like to do in that way. Yeah. It's fine. Yeah. But doing that way, sometimes very difficult. Because sometimes, especially when the whole procedure is extremely complicated, then the straightforward thinking cannot keep track of all the steps, all the details in those steps. It's very hard to keep track of them. Yeah. So then this time, recursive method helps a lot. Yeah. So that's something we want to discuss. Yeah. All right. Some problems can be solved by both ways, non-recursive and recursive way. Yeah. Large part of the problem can be solved in this way. Yeah. So in that situation, you can compare which way you like to use. Yeah. Each one has its advantage and disadvantages. Yeah. Next, I will compare a few points. Yeah. All right. So the main reason we use the recursive method is its power. It is very powerful. So what do we mean? Its power. In what sense? The power, right? Yeah. In this meaning, yeah. When you are given a very complicated problem, if you want to use the straightforward way or non-recursive way to solve it directly, it is extremely complicated. In that situation, you can try the recursive method and it can solve the problem in a much easier, in a much easier way. Yeah. So let's say that in a much easier way. Yeah. Much easier, that means, so you look at the steps, just a few steps, you can solve a so complicated problem. So that's the impression people can get from if you use the recursive method. Yeah. The problem, so complicated. It looks like you need to write a lot of code, but if you can find the right way to write a recursive code, then your code is very compact. In our next video, we will see that. We will see that concrete example. So you can appreciate the power of the recursion. Yeah. That's the main advantage. Yeah, some relatively hard problem can only be solved by recursion. Yeah, so here I put a parenthesis only, because it is not easy to argue that is the only way, right? Not easy to argue, yeah. Because some other people can claim there is a non-recursive way to solve it, yeah. But actually extremely complicated. So nobody like to use it, even if someone can do it, but nobody likes to use it. That's the situation. Okay, people mainly like to use the recursive way to solve some kind of complicated problems. Yeah. All right. Now I want to compare two different ways. The first way, non-recursive, we call the iterative way, because we do iterations, right? Iterative way. The second, recursive way. So we compare. I just want to compare, two aspects. Two aspects. The first, resource consumption. Iterative way consumes less resource compared with the recursive way. Resource, we talk about memory resource inside the main. Excuse me. Inside the main memory. Memory space, right? Yeah. Remember our secondary resource, memory, storage space, that resource. Yeah. Iterative way consumes less memory resource comparing with the recursive way. Harder implementation. Yeah, because here I'm talking about some of the relatively hard problems. If you want to implement all the details, extremely complicated. Yeah. All right. The other side, more resource. Yeah. If you want to do it recursive way, in general, you need to use more memory resource. I will explain why more memory resource, but easier implementation. Yeah. Here, let me briefly explain why recursive way uses more memory resource. Yeah. When we call a function recursively, okay, so we need to call the same function for a smaller parameter value. So that's typical recursion works, how it works. Yeah. But inside the main memory, how the programming language implements that idea. So inside the main memory, the programming language uses a stack to arrange that recursion. Okay, yeah, all right. Because when you call the function at a larger value, then suppose you want to evaluate function f of n. Okay, but f of n relies on the function value f of n minus 1. Okay, you assume f of n minus 1 is known, but actually in your program implementation, it is not known. So the only way to deal with that unknown situation, push it into the stack n minus 1. All right, but in order to get f of n minus 1, it relies on the function value f n minus 2, and so on. Okay, and when you reach the bottom, you need a base case, f of 1 value. Okay, you need to know f of 1 value. All right, so after it finally it gets a known value f of 1, then it will apply to, higher level step to get f of 2, then apply higher level, backtrack, and finally get that value. So you can see, in order to implement recursive algorithm, you may need a very deep step, very deep stack. Okay, so the stack could be very deep. Right? The stack consumes a lot of memory resource. So that's the main reason. It consumes large amount of memory resource. That is its biggest drawback. Other than that, everything else works perfect. Yeah, perfectly. Yeah, just this big drawback. Yeah. So that tells us sometimes if you have two options, it's better to favor this non-recursive, favor this option, because you will use less resource. All right, so this point in our discussion, because this whole module is about recursive algorithm. So in our discussion of the whole module, I will get to this point several times, because this is a big important point, several times. All right, so let's go to the next step. Next, we want to look at a concrete problem. Very easy, but mainly we try to get idea. All right. Problem number 8, calculate the factorial. That's very easy. You know the factorial, right? Yeah. Now, let's look at the idea, the method, the thinking. Given a non-negative integer n, non-negative integer greater or equal to 0, okay? It can be 0. We allow it to be 0. Find its factorial and that exclamation sign factorial. Very famous, very important. Our first method, non-recursive, iterative, because we're familiar with this method. Definition, the factorial we define in this way. The product of the consecutive integers from 1 through n. And we assume 0 factorial equals 1. Is this natural? Right? Yeah, think about this. Why 0 factorial equals 1? Can you imagine that? Does it make sense? Right? Yeah. It looks like not quite, following our intuition, right? So our intuition, most people, I believe, intuition, we like to give 0, right? Yeah. Not 1. Yeah. Yeah. All right. We will see that later. We will see that later. Next slide, we will explain that. The implementation of this, very easy. So here I just do not. My computer slow again. I don't know. So many times, very slow. All right. So so everyone knows how to implement. Method 2, recursive. This time, we want to change idea. It does not mean we try to improve, does not mean that we try to understand recursion. Using the simple example, we try to understand recursion. Idea. So what is the idea? The idea using recursion here, so it is a general problem solving method. It is very important problem-solving approach. Near the end of this semester, we will have a module. We will talk about dynamic programming, module 7. In that module, the whole technique is based on recursive algorithm. The whole method completely rely on recursion. So we will learn more in that module another time, module 7. All right. This one, we will use this another important problem-solving approach, divide and conquer. So everyone heard of it. Divide and conquer. It is a big, important problem-solving approach. In our next module, the whole module is for this topic, divide and conquer. But here, because we are here, we get our first view on this divide and conquer. We need to use divide and conquer. So the first time of this class, we do it, divide and conquer. All right. Next, why this divide and conquer helps us solve some relatively hard problems. So not this one. This one is not hard, but we're talking about the general case, because we notice that when the problem size is smaller, it is easier to solve. That's our experience, our observation. When you work on a problem of the current size, so our current size could be big size. We assume the problem of smaller size has been solved. So we do not start from scratch. We assume we have solved this problem of some smaller size. So then we can build up from there, not from the very beginning, from some steps in the middle. In that way, it could be easier to solve the problem of the current size. That's the basic idea. Because there is a gap from the known answer to the current unknown answer, there is still some gap. So we need to bridge that gap through recurrence relation. In that situation, you need to derive some recurrence relation. All right. Let us use factorial as example. The original function, we use f of n. Then we do the divide. So here, draw this line. So we cut this problem one slice at a time. The first time we chop the last number off. So we reduce the problem size. After we chop it off, we reduce the problem size one smaller. N minus 1 is the problem size. So this f of n minus 1, we assume we have solved it. So we start from there. In that situation, we can derive recurrence relation. F of n equals f of n minus 1 times n. And here, when we write this, we require n greater than 0. Otherwise, if n equals 0, you can think about, multiply 0, it is 0. So we don't like to see that happen, right? So that's why In this case, we assume n greater than 0. Yeah. All right. Next, with this, let's go back to the question we talked about in the previous slide. How to see 0 factorial equals 1. Here, it is the time we can see it. Okay, yeah. All right. First, let's rewrite the recursion formula in a different way. This time, because n is different from 0, we can do division both sides on n. So we get this formula. Okay, yeah, we get this formula. So it is true, after that, we plug in 1 both sides, n equals 1. It is allowed, it's greater than 0, it is allowed. So if you plug in, you get f of 0 equals f of 1 over 1. F of 1 factorial, we know 1 factorial is 1, right? So 1 over 1, it is 1. So you see, in this way, we proved 0 factorial equals 1. Yeah. So that means if we, so here you can see people assume 0 factorial equals 1. It's compatible with our recursion formula. It is compatible. Okay? Otherwise, if you just, if you assume 0 factorial equals 0, it's not compatible. No, because for when we use this formula, we will get a mistake. Right? Yeah. So that's the reason. Yeah. All right. So for this problem here, I just give you reference on our textbook. Yeah. If you like, you can study this textbook. Yeah. All right. Now, conclusion for this part. Conclusion. Yeah. Here, we use recursive algorithm to solve this factorial problem another time. It does not mean the recursive method is better than the iterative method for this particular problem. It does not mean that. It just gives us an interesting way to solve a problem. Okay? So we just want to use this simple example to help us get a better understanding of the recursive algorithms. That's it. So that's what we want to do in this video. All right, so let's stop at this point.